Welcome back, everybody. I'm very happy to have you here again. And with me now is Dr. Nils Mohmeyer of trinamiX. And yeah, in this webinar, the BASF subsidiary trinamiX demonstrates its mobile near-infrared spectroscopy solutions. And yeah, I'm very happy to hear what they can tell us about that. In the first part, we will have a quick video of trinamiX where they will demonstrate how it works, what it can do. And afterwards, we've got a few minutes to do some Q&A with Dr. Mohmeyer himself. So you can pose your questions in the chat anytime, and then we will just do a quick interview afterwards. But for now, I would just say, let's start the video, have fun. And yeah, I'm happy to have you all here.
Hello and welcome to our webinar for the trinamiX Spectroscopy Solution. trinamiX is a brand of BASF SE, and we've just recently launched a new solution providing new ways of plastic sorting. I'm Adrian and this is Elizabeth. Elizabeth, you will join me today during the presentation and also introduce the Alliance to End Plastic Waste.
Yes, thank you very much. Welcome from my side. Thank you for inviting me today. The Alliance to End Plastic Waste is a non-profit organization headquartered in Singapore. It has been co-founded by BASF in January 2019, and it is unique because it unites companies from the entire plastic value chain. The Alliance has the vision to end plastic waste in the environment by focusing on 4 areas: waste management infrastructure, innovation, cleanup, and education. Therefore, it is very important for us to understand how specific types of plastic are recycled and can be sorted in order to be able to move this precious material up the waste hierarchy. Therefore, I'm super excited to be here today and to see what you guys at trinamiX are doing.
So let's start with a demonstration. I would like to demonstrate our entire solution, which consists of the spectrometer, which is basically the hardware we have. It fits nicely in my palm, so it's a portable device. The measurement head is on top, but our solution also consists of the cloud, which runs the algorithms or chemometry, and the results are then being displayed on the smartphone app, as you can see here. So let's do some measurement. I would say we start with this coffee capsule. I put it on top of the spectrometer, push the button, so the measurement starts, it's being calculated, and the result is being shown on the smartphone. When you have measured a couple of times, you can look into the history of your measurements where you can see the spectra and when you have measured it. So at any time you can go back in the history and see whatever you have measured. We also have a couple of other samples here. This is a kid's swimming aid, which is also some typical plastic piece that we can distinguish from other materials. As you see, the result is being displayed very fast. And as a third sample, we have this kid's toy. As you see, we have a summer vacation topic here today. I hope plenty of you can enjoy a nice summer vacation. And this one is PE. When you have performed a couple of measurements during the day, you can also log into the web page and look into your history where you can see all these measurements and you can make an analysis, you can download it, you can see trends, and you can add additional data to these measurements. Now that we've seen how the solution works, I would also like to introduce the theory behind it. So, as we've learned, this is our spectrometer, which has a measurement head, and the idea is that this spectrometer is sending out light, which is being reflected by the surface of the specimen and being caught by the detector, which is inside the spectrometer. This detector is then responsible for translating the optical signals into electrical signals, which are being sent into the cloud, where our smart algorithms translate them into the answer. Actually, these smart algorithms compare the signal that they receive from the spectrometer with the database that we have already put into the cloud. The results then are being sent back to the smartphone where they are being displayed and shown to you in the way you've seen. The differentiation of the material is actually done by looking at their spectra. As you can see in the slide we have shown to you now, each material type has a different spectra, which is basically like a fingerprint. And analyzing the material is just looking at the spectra and comparing it to what we already have in the database. Now we show to you a slide which is showing a list of material types that we have already in the database. In case you don't see the material that you would like to analyze, please reach out to us so we can add it to the database and provide the full solution to you.
Thank you, Adrian, for the super interesting demonstration and explanation. I do have a couple of questions. So I saw the data displayed on the smartphone and the algorithms also run in the cloud, but is it also possible to access the information from a regular computer?
Yes, it is. We provide a platform so each user can log in and see all the measurements he did in the past. It's also possible to add additional data to these measurements, just like pictures, and over time you can see trends and make further analysis with these data.
And what are your next steps? How will the technology adapt to the challenges that the industry faces in the future?
Well, our system is very open, so we can always adapt to customer requirements or to future market trends. We do this by adding new materials like composites or new blends, or even more complex measurement tasks like multi-layer foils. We can also add something like textiles for textile recycling. So this means that for our users, this is a really forward-minded solution. They profit from every improvement we do, and actually we improve from each user that uses our solution.
And this means that the user doesn't have to buy new hardware?
Exactly. All this works with the same hardware.
Great. So this is really impressive technology. Thank you so much for demonstrating it today.
Thank you very much for joining me. Goodbye.
Bye.
Well, Dr. Mohmeyer, thanks to your colleagues for that quick demonstration of your technology. Feel free to pose any questions. I've got the first one already here, and it has to do with the mobility of the solution. And it is about the use case for that, because you can, of course, it's pretty much handheld, but what are the best things about that? What would you say? How does it come? What's the best use case for it?
Yeah, so in general, or first of all, good morning to everybody from my side. To the answer to your question, for the time being, it's not really new to have a NIR spectroscopy also for plastic sorting in place. Big plans are already in place. Also from the lab, it's a well-known technology, NIR spectroscopy. So therefore, we didn't develop this technology on our own. It's already established, but we made it handheld, we made it mobile, and you can use it through your entire production facility. Every employee can use it, have it in the pocket, and use it very quick on the spot check to evaluate which plastic do I have in hand.
And where would you say is it? What kind of company would have the best use for that?
So if we really focus on the plastic detection, the one group of potential users might be the recycling companies. So getting different types of post-consumer or post-industrial polymer waste streams. And to get an idea, do I have really a polyethylene or polypropylene in hand? Then they can check very fast with our technology, is it polyethylene, polypropylene, or one of the other plastic materials. In addition, some of the, in Germany, they are called Wertstoffhöfe, so where everybody will bring their waste to. Also, those companies or those shops might be potential users of our technology to detect the different polymer types, to sort it, and to create a higher value, and to be able to sell at a higher price those polymer waste streams.
Yeah, perfect. Thank you so much. Next question is if whether you can give a roundabout indication about the pricing of a single unit. Is it possible to say something about that?
Yeah. As I already said, the technology is not new and well known through the entire industry. For example, for benchtop devices, you have to pay more than 50,000. Nevertheless, we were able to reduce the price by one order of magnitude. So we will be below 10,000 euros for one solution for the plastic application.
Yeah, that seems pretty good if you say it like that. Very nice. Yeah, and do you think it's going to be even used maybe in households in the future? So will we be maybe in the next 50 years or something? Will we be at a level where we can do sorting with a technology like that, even at a consumer level?
Yeah, for sure, and that is our intention, that we bring our solution to different B2B businesses and different industries. But on a long run, for sure, due to our sensor, it's a very thin sensor chip. So therefore, you can integrate this sensor solution into every smartphone. And on a long run, we hope that we can bring our solution to the end consumer for all different applications. We are already active, plastic sorting or determination of protein level of your chicken or the fat content of cheese.
Well, thank you for that. That seems pretty interesting. I've got here the next question about whether it works on multi-layer plastics. Can you say something about that?
Yeah, we work on that currently with the first launch of the first app version. We have just the standard plastics in the system, so roughly up to 20 different types. But currently we work also on the solution for the multi-layer that we will integrate also in the coming months into our solution.
So in the coming month, all right, that's a nice time frame, I believe. All right. Yeah, and one more thing I've seen, which I found pretty interesting, and I wanted to ask about. Your colleagues have talked a lot about the cloud solution. So Internet of Things and the data collection are going to be going to be what will drive the next 10, 20, 30 years. What do you think will be the use case for these types of data I can collect?
Actually, you can collect all different data you are interested in. But as already explained by my colleague Adrian in the video, the clear advantage of this cloud and KI solution is, for example, with the example of the multi-layer film question, there is no need for the user to download something in addition, or to link the spectrometer to a laptop and download something. No, due to the cloud solution, we will push the new solution into the app of all the users, and then directly they have the solution in their hands.
Well, thank you so much. Perfect. Yeah, Dr. Mohmeyer, our time's up. Thank you so much for being here.
Thank you.
For helping us understand the next solution in that sector. I would invite all of you who are viewing this to our next webinar with Michael Zeppenfeld from Dobstadt, who will talk about mobile modular Anlagen- und Aufbereitungskonzepte. For all of you who are speaking German, the next one will be in German again. Thank you so much, Dr. Mohmeyer. The last words are yours. Do you want to say anything to all our viewers?
Yeah, for sure. Yeah, thank you for joining the webinar. I hope you understood our solution and you are curious to get more details on that. So please feel free to give me a call, send me an email, and we'll be happy to send you an answer back.
Yeah, all of you are invited to the booth of trinamiX. They have a booth at EREC. You can find their contact data there, and I think you can chat with them directly. So feel free to reach out. I think they will be more than happy to help you out with any further questions you've got. Thank you.
So, thank you. Have a nice day.
Goodbye.
Bye-bye.